Chapter 13, Graphing and Writing Linear Equations. So by the look of the picture, you can obviously tell we're going to be working a lot with the coordinate plane and the equations of lines that are going through it. So before we get started with the actual graphing, we have two prerequisite skills that we have to revisit. And the first one is evaluating expressions using order of operations. So they give us this expression, so 2xy plus 3, and then in parentheses x plus y, when x equals 4 and y equals 7. Now remember, a variable is just in place of some unknown number that we don't know yet. So whenever they're giving us these values for x and y, all they want us to really do, as you can see in the little note there, is to substitute it for x and y and then simplify it all the way through. So it's already been done. The 4 and the 7 have kind of replaced our x and our y in our expression. So now we just have to go through the order of operations. Now don't forget, for our order of operations, we want to think of PEMDAS. So parentheses, exponents, multiplication, division, addition, and then subtraction. So if I look at this expression here, that plus sign is kind of breaking up my expression into two halves, because I see in the first half I have this multiplication going on between the 2, the 4, and the 7, and then in the second half I have to do 3 times the sum of 4 plus 7. So I want to simplify those before I can add those two numbers together. So for 2 times 4 times 7, so 2 times 4 is 8, and then 8 times 7, of course, is 56. Now on the right side there, 4 plus 7 is going to give me 11, so I really have to multiply 3 times 11 before I can add, so then I would end up with 56 plus 33. Final answer of 89. Now I'm sure you're wondering, why are we doing this by hand when I have this calculator next to me that will do all the work for me? You're absolutely right, you're more than welcome to use calculators, but make sure you understand the process of why you're getting your answer. So at the very least, if you can at least do the multiplication in a calculator but write out the steps by hand, you'll have a better understanding of why PEMDAS gives you the answer that it does, because there will be some questions on the PSSAs. We are not permitted to use a calculator. I want to make sure that we're okay with this process. So for each one of these next 3 questions, I'm going to write out the steps and then I'm going to come back and explain them. So this will be the point where if you want to pause, complete these next 3 questions, and then just check with these whenever you're done. Go ahead and do that. Now the first one's relatively simple. You have negative 8 times A times B, and they're telling us that for each one of these, A is 1/4 and B is 6. Now, since you're just multiplying, multiplication is commutative, so you can do it in any order you choose. But the way it's lined up is actually pretty convenient, because if we have negative 8 times 1/4, remember that's the same as saying negative 8 divided by 4. So that, of course, gives us negative 2, and then finally negative 2 times 6 is a negative 12. Okay, for number 2, a little bit trickier. We have 16 times 1/4 squared. Notice the squared is only with the A, it's not attached to the 16, and then minus 4 times 6. So I did kind of 2 simplifications here first. First I squared 1/4, so 1/4 times 1/4 would give me 1/16 since the exponent comes before multiplication. And then on the other side of the subtraction sign, I did simplify 4 times 6 since that was the only thing going on there. And then on the left side, I had to go back, take 16 times 1/16. So really just 16 divided by itself would give us 1, and then minus 24 is still kind of being dragged down. Finally, 1 minus 24, of course, is going to give us a negative 23. All right, for the last one, I have 12 times 1/4 plus, in parentheses, 6 minus 1/4 minus 4. Now, the first thing that has to be done is definitely this multiplication that's happening between the 12 and the 1/4. So 12 times 1/4, so 12 divided by 4, it's going to leave us with 3. And then inside the parentheses, we should simplify the subtraction because it is in parentheses for a reason. So if we have 6 minus 1/4, that's 5 3/4, and then minus 4 more whole numbers. So 1 3/4 is left, and 3 plus 1 3/4 is just 4 3/4. So hopefully you checked your answers on the calculator so you knew those should have been your answers when you were finished. Now the last skill we have down here is plotting points. Now we just did transformations back in chapter 11, so hopefully it's not too far from our heads, but we need to make sure that we are naming these points correctly. So the first thing to point out is that every point is written in the style of x, comma, y. So we are always going to go horizontal first, and then we're going to name our point vertically. So they're asking us to write the ordered pair that corresponds to point U, which is down here in this corner. So if I kind of track it from the origin, I will go to the left 3 and down 4 units so that you can see the numbers correspond right there on the grid. So the point for you would be -3, -4. In the next example, they're essentially asking us to go backwards from what we just did. They're asking us which point is located at 5, -2. So remember x, then y, so I'm going to start at the origin and go to the right 5 units, and then down 2 to -2. So I can see there I landed on top of point T. So the next 4 questions are pretty self-explanatory. They go right along with what we just did. So go ahead and do those on your own, hit pause, and then come back and check your answers. Okay, so hopefully your answers match up with mine. The only one I really want to go over is number 4 when they're asking which point is located in quadrant 2. Now, the setup of the quadrants, as you can see, they're split by the axes. So we have 4 main quadrants. The numbering of them actually starts in this first quadrant in the top right, and it actually follows a C pattern. So when you think of the quadrants, think of like you put coordinates in a quadrant, which begins with C. So that's kind of the style that it follows. So quadrant 1 is in this top right-hand corner where both values are positive, and then it counts up from there. So quadrant 2 would be the top left, which is why N is in quadrant 2. We have quadrant 3 down below in the bottom left, and then finally quadrant 4 is in the bottom right. So for 13.1, we're going way back to the beginning, and all we're going to do today is just graph linear equations. So you can see by the key idea, a linear equation is just an equation whose graph is a line. So we all know that a line is straight with absolutely no curves. So if you look at these 2 images, we have one linear equation and then one non-linear equation. And I hope you're thinking to yourself that the one on the left is the linear, because you can see the graph on the right, it definitely has this U curve going throughout the graph. So essentially, after you're done graphing all of our equations that we have this section, they should definitely look like this graph on the left. So in order to get our equation actually on the graph, we need to use the points that are on the line. And these points are really the solutions of the equation. So if you look at this first example, we want to graph y equals x plus 1 onto the coordinate plane. So all we really have to do, if you could think back to the prerequisite, is plug in values for x, see what that turns y into, and then turn those 2 numbers into a coordinate, because as we know, our coordinates are all in the form of x comma y. So we kind of have some freedom whenever we're choosing our points of x and y, but a good way to go about it is pick one negative value for x, pick 0 because it's easy, and then pick one positive value. So again, if we just try and make this as easy as possible, let's look at x when it equals -1, 0, and 1. So for all of these equations, we're going to have some type of table here with our values. So now that I've established what I kind of want to plug in for x, now I'm going to solve for my y. So if I look at the equation y equals x plus 1, when I plug in -1 for x, I end up with the equation of -1 plus 1, which we all should know that equals 0. So in this case, our y is equal to 0, meaning that the point that is a result of that is -1 comma 0. And I basically just have to do that for all of my values of x. So for the next one, if x equals 0, then I end up with the equation that y equals 0 plus 1. Once I simplify, I get that y equals 1. So our second point of the equation is 0 comma 1. Finally, we have when x is equal to 1, so we end up with the equation that y equals 1 plus 1, which of course is 2. So our final point is going to be 1 comma 2. So now that I have all 3 of my points, I want to place them on the graph, and whenever I go to connect my points, I should end up with a straight line. So I have -1, 0, 0, 1, and then 1, 2. And as you see, as I go through and connect them, I end up with a straight line for my linear equation. So when asked to graph these equations, you pretty much have 3 steps. So the first one you can see there is to make a table of values, then you plot the ordered pairs that you created from your solution, and then we draw a line through the points. So if we're looking at the graph of y equals -2x plus 1, we're going to do the same exact thing. Pick that same 3 numbers for x, so in this case -1, 0, and 1, and then we're just going to go ahead, plug it in to get our values of y, so then we can get our ordered pairs. We don't necessarily have to pick these 3 numbers for x, but in my opinion, they are the easiest to work with, especially for this equation. since it is very simple numbers. Okay, so whether using your calculator or just doing some mental math here, we want to get our values of y. So when we plug in -1 for x, we do end up that y equals a +3, because we have -2 times a -1, which is +2 plus 1 gives us 3. So our first point is -1, 3. Our second point, probably the easiest, plug in 0 for x. We end up that y equals 1. So our second point is 0, 1. And finally, plugging in a +1 for x is going to leave us with y equals -1 for a final point of 1, -1. So now that step 1 is complete, step 2, plot the ordered pairs. So I'm going to go to my graph, plot the points -1, 3, 0, 1, and 1, -1, and then last but not least, draw a line through the points, and there's my linear equation. So if you notice with these past two graphs, they've been in a diagonal fashion, but we can actually have lines that are horizontal or vertical. The equations look a little different, but we still have our variables of x and y involved in some way. So if you look at the key ideas, a horizontal line is actually represented on a graph by the equation of y equals some number, with a line passing through that y coordinate of whatever number it is. So if it's 1, it's going to pass through where y is equal to 1. If it's -4, it's going to pass through horizontally where y equals -4. Now, since y is the vertical axis, you may think this is a little backwards. It is only because the horizontal line is going to pass through our y-axis, which is why it's represented with the equation of y equals, because it's crossing through its own axis. So if you look at the equation for a vertical line, it's exactly what we would kind of expect if x equals some kind of number, and notice that it's going to cross over the x-axis. So this one's just going to take a little bit of memorizing which one is which, but is a good key thing to remember is that the line should be crossing over its axis. So if you look at the equations of these types of lines, you can see that when they're asking you to graph y equals -3, there's no x for us to plug in. So that should kind of be a tip-off right there that this is definitely some different kind of line. So if y equals -3, they're saying that it can only equal -3 and nothing else. Again, here's our y-axis, so we want to make sure our line is crossing over that y-axis at y equals -3. So to graph this equation, all we need to do is put a horizontal line crossing over that point where y equals -3. And almost just as easy for number 2, again, we're seeing x equals some number. We don't see any y values to plug in and get a coordinate. So if x equals -2, again, here is our x-axis. Here is where x equals 2. So to graph this line, all we're going to do is put one vertical line going straight through that point where x equals 2. And again, notice that it's crossing over the x-axis. So for these next couple examples, I want you to try and graph these linear equations on your own. If you notice, for numbers 1 and 2, you see both variables are involved in the equation. Y equals 3x, and then y equals a -1/2 x plus 2. So for these two, you want to follow our 3-step process that we did on the first page, where we make our table of values, we plot the points, and then we draw our lines. For 3 and 4, you should end up with a horizontal and vertical line depending on which variable is setting up the equation. You can plot all of the lines on this same grid. You can either use a different color or maybe just label each line as you go so it doesn't get mixed up. But go ahead and pause. I'm going to do all the work on here and then hit play when you're ready to check. Okay, so hopefully your graph turned out pretty similar to mine. One big thing I definitely want to point out is my table of values for number 2. Now remember it being I said, you can use whatever you want, and since I see here in my equation that I'm going to have to be multiplying whatever number I pick by -1/2, I chose even numbers, so I used -2, 0, of course, and then 2, which made my points that I plotted even as well. You could have plotted half values, you would have gotten pretty much the same exact equation as I did, but make it as easy as you can. And then just to reinforce, x equals -4 should be a vertical line where x equals -4, and y should be a horizontal line for number 4. All right, so of course we're going to finish up with a real-life application. Now all of these equations that we've been graphing can stand for actual situations. Not all of them are just numbers kind of thrown into an equation. So for example 3, we have the wind speed y in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. So they want us to graph the equation, but I first want you to make sure you kind of like look at the graph itself. So the first thing you should notice is that it's all positives, it's all in quadrant 1, because it doesn't really make sense to talk about hours in terms of negative values. Also, we have this break here because we see that we're going to be graphing some pretty large numbers. So instead of having to graph 1 through 66, a break is just saying, hey, there's some numbers in between here, but we don't need to see them. So now that I'm ready to graph, for my table of values again, I want to make sure I'm using all positive values for x. I can still stick with 0, but I'm not going to be using -1. So I'm just going to use 0, 1, and 2, since those are the smallest 3 numbers that will fit nicely into the equation. And as I go through and plug them into the equation, if I plug in 0 for x, I end up that y is actually equal to 66 itself. Plug in 1, y is equal to 68. And I plug in 2, and I get that y is equal to 70. So the 3 points that I'm going to go plot are 0, 66, 1, 68, and 2, 70. So after I get my line on there, I'm left with the question, after how many hours does the storm become a hurricane? Well, if you notice the information over here, a tropical storm becomes a hurricane when wind speeds are at least 74 miles per hour. So essentially they're asking, when have the speeds reached 74 miles per hour? I can do this one of 2 ways. I know that my time is my x given by the information in the paragraph, so I can go to where my graph sits at 74 and then trace over to my graph and see what my value of x is. So if I follow it back down, I can see that x equals 4, meaning that after 4 hours, the hurricane has started. I could also refer back to my table of values, because if I were to keep plugging in values for x, if I plug in 3 for x, I would end up at 72, but that storm hasn't become a hurricane yet. Go to 4, and then I would end up at 74 miles per hour. So whether you use the equation or if you use the graph, you should get the answer of after 4 hours. Okay, so what if we change this up a little bit? So for the on your own, it says that the wind speed of the storm is y equals 1.5x plus 62. When does the storm become a hurricane? Now notice I'm saying we don't need a graph for this, because we know that the speed of the storm is our y and the time elapsed is our x. So if we're trying to figure out a time, that means that we have to set up our equation so that we have to solve for x. So in this case, again, it takes 74 miles per hour in order for a storm to become a hurricane. I'm going to plug in my 74 for my y, and then I'm going to leave the rest of the equation alone because I'm trying to solve for my x. So after I've correctly plugged in my 74, it just turns into a 2-step equation. So first, subtract 62 from both sides. So we end up with 12 is equal to 1.5x. And to finish up, we just divide both sides by 1.5. And 12 divided by 1.5 is going to leave us with x is equal to 8. In this case, it is 8 hours. So as you can see, there's a lot that we can do just given an equation. We can create a graph, we can solve different types of problems. So I want to make sure that we also know how to create an equation given information. So for this very last example, we're going to create an equation given this situation. You have $100 in your savings account and you plan to deposit $12.50 each month. Now we know our equation is going to start with y equals. So now the question becomes, what do we do with the 100 and what do we do with the $12.50? So in this situation, I see the 100 as our starting amount because I put it into the savings and then it stays there until I either add or take money out. But then if I'm planning to deposit $12.50 each month, think about it kind of logistically. After 1 month, I'm going to add $12.50 to that 100. After 2 months, I'm going to add $25. So actually, my $12.50 needs the X attached to it because whatever number of months I've saved, that's what I need to multiply before adding it to that 100. So to sum this up, my Y is the amount in my savings account. The 100 is my starting value, so what I first put into my account, and then the $12.50 is the amount that I deposited each month, which is being represented with my X. So one last question to top it off. After how many months will it take you to save enough money to buy 10 acres of land on Mars? This came from the book, so don't question it. So as you see, 10 acres are $175, so that's how much we need to save. So if I look at kind of my outline right above in part A, my 175 is actually my Y. So I should have 175 is equal to my 100 plus the 1250 X. And then of course I'm going to solve for X since that's the number of months. So just as before, we have a two-step equation here, which I'm going to draw in my balance line first. I want to get the numbers away from my variables, so subtract 100 to start. So I end up with 75 is equal to my 1250x. And to finish up, divide both sides by 1250, and if you do 75 divided by 1250 in your calculator, we see that x is equal to 6 months. So it's going to take you 6 months to save $175.